Alright, so we're going again. We're continuing with the topic of matrices. So this is the third in our little series here, dealing specifically with the 2 by 2 matrix. Alright, so we covered the determinant in the first video. In the second video, we looked specifically at the case where the determinant is equal to 0, which is where we refer to the matrix as a singular matrix. In this third video, we're going to look at the inverse of a 2 by 2 matrix. Alright, so let me just start by writing now the formula, and then we'll just do some examples, and then of course you have your questions to practice afterwards. So if we have a matrix A is equal to A, B, C, D, then the inverse of this matrix, A minus 1, is equal to 1 over the determinant multiplied by a particular matrix that we're going to write out the matrix first and then talk about it. Alright? So this matrix is formed by switching A and D. So this will be D here, A here, and then you change the sign of B and C. B and C. Alright? So this is supposed to be minus here. Right. So we change the sign of C and B and we switch A and B. Right? So you would recall in the very first video I would have mentioned that the determinant is the key, the first key building block. Right? So this here is where the determinant comes in. So if you cannot find the determinant of a 2 by 2 matrix, if you cannot find the determinant of a 2 by 2 matrix, then you will not be in a position to find the inverse. Alright? So again, let me just reiterate. To get to the inverse, the first step is the determinant. So make sure that you have the determinant locked down. So then you can take the next step, which is this fellow here, which we refer to as the adjoint of A. Alright? So in many books, you would see that the inverse is written as A minus 1 is equal to 1 over the determinant by the adjoint of A. Alright? This is the same as this, but I made sure to write it out like this so that you can see exactly what happens to the elements of A. Right? This we already know how to find the determinant, and with the adjoint you switch A and D and you change the sign of B and C. Alright? And that is all there is formula wise in terms of finding the inverse. Of course, the actual practice of doing it is a little more complicated, and we're going to go through some examples now. Alright. Alright, so we're going to go through a couple random matrices just to give you the flow of how this thing is done, and then I'm going to leave you to do the examples accompanying the video. Alright, so random matrix. Let us say we have a matrix B is equal to 3 minus 4, 2, 5. Alright, and we want to find the inverse of that particular matrix. So the first thing we do is find the determinant. We know that the determinant of B is equal to 3 by 5 minus 2 by minus 4. 3 by 5 is still 15. 15 minus 8, which is the same thing as 15 plus 8, which is equal to 23. Alright? So the determinant of B is 23. Now, with that knowledge, we're in a position to find the inverse. And the inverse will simply be, and watch this now, so that B minus 1 will simply be 1 over 23 by, what we're doing here, we're going to switch the 3 and the 5, right? So you put the 5 here and the 3 down here, which is what I would normally do, and then we switch these two signs here. So minus 4 will then become plus 4, and plus 2 will then become minus 2. Alright? And my advice to you is to leave the inverse just like that, because that will be required when we come to the point of solving simultaneous equations using the matrix method. Alright? So I'm going to work one more example and then leave you alone to finish off the rest. C as B. Alright, so let us take another example, G. Let's say the matrix G is equal to 0, minus 6, 4, minus 2. Alright? And we want to find the inverse of that matrix. So the first thing we do again is to find the determinant. So the determinant of G is equal to 0 by minus 6 minus 2 by 4. Because 0 minus 8 equals 0 plus 8 equals 8. So the determinant of G is 8. Now, with that knowledge, we're going to find the inverse of G. So we're going to say now that G minus 1 is equal to 1 over 8, 1 over the determinant, alright, multiply by the adjoint. We switch in the 0 and the minus 6 on top, 0 below, and we switch in the sign of these two. So minus 2 will then become plus 2, and plus 4 will then become minus 4. And that is all there is to finding the inverse of a 2 by 2 matrix. Alright? Now, of course, further to this now, we're actually going to use the inverse to do something else. Alright, but we will get that in the next video. So again, I just want to encourage you to practice the questions that accompany this particular video. Alright, so in the next video, we're going to look at using the inverse of a 2 by 2 matrix to solve simultaneous equations.